Why are we exploring space? The answer is vast, complex, and nearly impossible to answer. In reality, space agencies across Earth are exploring space for various reasons, but the one thing they can all agree on is knowledge. The universe is massive, complicated, and yet so far out of reach. We aren't even sure if other life exists off Earth, but NASA is investigating that. Among the dozens of other missions NASA plans to roll out in 2024, the search for life continues with Europa Clipper. Scientists are nearly certain Jupiter's moon Europa has the potential to harbor life underneath its icy surface. Europa contains the essential ingredients for life: water, chemistry, and energy. Liquid water is an essential factor for the complex chemistry that brings life to Earth. Scientists have predicted that there is a salty ocean beneath the layers of ice of Europa's surface, and they think there might be more water on Europa than there is on Earth. But how did scientists make this hypothesis? How did we get here? Europa, Io, Ganymede, and Callisto were discovered by Galileo in 1610. Nearly 400 years will have passed before any detailed views of their surfaces were observed. The uniqueness of these Galilean moons shocked scientists, a fact that speaks volumes because out of 90 moons, these 4 made an impact. Even more so, Europa piqued the interest of many. In the 1960s, ground-based telescopes observed Europa's surface composition and believed it to be mostly water ice. Several spacecraft have flown by Europa, such as Pioneer 10 and 11, but it wasn't until Voyager 1 and 2 that NASA received the first detailed images of her surface. Voyager 1's closest approach to Jupiter happened in March of 1979, with Voyager 2 not that far behind. The best imaging resolution of the Voyagers was limited to roughly a mile and some change per pixel. The images revealed a surface brighter than that of our moon, crisscrossed bands and ridges, and a surprising lack of large impact craters, tall cliffs, or mountains. The surface of Europa was surprisingly smooth compared to Earth's moon. Despite neither of the Voyagers passing close to Europa, their images were high enough quality that researchers could make observations. For instance, scientists noted some of the dark bands had opposite sides that matched like a puzzle. The cracks had separated at some point in time, and dark, icy material appeared to have flowed into the gaps. So what does this mean? The dark bands and cracking of the surface provided enough evidence to prove to researchers that Europa's believed oceans were once active. They were once moving, if not still currently in a state of motion. But that wasn't all the evidence collected though. The surprising lack of large impact craters on the surface was another telltale sign that something was going on with ice. Meteorites have constantly bombarded Europa over billions and billions of years. When Voyager images showed only a handful of impact craters, researchers only became more convinced in their theory. Think about it. If Europa was the catch-all net for meteorites, wouldn't the surface be spotted with craters all over? The lack thereof adds to evolving theory that the surface Voyager was seeing was relatively young. Icy volcanic flow or settling of the icy crust underneath its own weight could all be possible reasons why the surface looks the way it does. Further research of the images shows that the patterns of the longest linear features on the surface don't fit the predicted patterns of fractures Europa should have had. The linear features didn't match up with what should have been created by tides as the moon orbits Jupiter. Scientists determined that the patterns would fit if Europa's surface moved independently and was not locked to the rest of the interior. This would also be the case if a layer of liquid or warmer ice existed between the crust and the deep interior. These findings intrigued scientists and led to a strong excitement for the Galileo mission, which launched in 1989 and entered Jupiter's orbit in 1995. Galileo's primary mission included observing the 4 Galilean satellites with repeated flybys of each one. The information sent back to Earth about Europa was so thought-provoking, even mind-boggling, that the mission was extended to make a total of 12 close flybys. Data from the missions included images of the icy moon at a range of scales. New details were discovered with each image. Arguably the most important measurement made by the Galileo mission was just how much Jupiter's magnetic field was disrupted in the space around Europa. The measurement strongly implied that a special type of magnetic field was being created within Europa by a deep layer of electrically conductive fluid beneath the visible surface. And based on Europa's icy composition, researchers think the most likely material to cause such a phenomenon is a global ocean of salty water. After decades of speculation, theories, and dramatized pop culture cameos, NASA has decided it's time to seek some real concrete answers. The Europa Clipper mission seeks to discover whether or not Europa harbors a secret ocean underneath its icy surface. The spacecraft will measure a variety of things that will indicate independent moving fluid. For example, the Clipper will be measuring the amount of flexing in the ice due to tides. If an ocean does exist, the tide should deform the surface by about 100 feet. But if the moon is frozen through, the tides would only stretch the surface by 3 feet. Great interest will also be taken in the composition of the reddish-colored material on the surface. Scientists want to know if this mysterious material holds clues to the composition of the ocean and whether or not the material is cycling between the surface and the interior. Europa Clipper, the spacecraft tasked with such a mission, is a robotic solar-powered craft built with the intention of conducting the first detailed investigations of Europa. The spacecraft will orbit Jupiter and make roughly 50 flybys. The Clipper is looking for any inclination that Europa could support life. With her solar arrays fully developed, Europa Clipper spans more than 100 feet in length, roughly the length of a basketball court. The main body of the spacecraft consists of its avionics vault, radio frequency module, and propulsion module. In addition, Clipper is also outfitted with 24 engines not to strain and possibly seize just 1 or 2. Europa Clipper has been equipped with 9 different instruments to conduct the mission, and they are the most advanced and sensitive that have ever explored space. Some of the sensors are installed on the nadir deck, which stabilizes them to ensure they are oriented correctly during the flybys. The 2 instruments were designed to capture gas and dust, faces instead of the direction of spacecraft motion. Radar antennas have been mounted directly onto the spacecraft's solar arrays. The magnetometer and plasma sensors are on a boom that extends from the craft, reducing obstructions and magnetic interference. The spacecraft's electronics will be enclosed in a vault, with walls made of 1/3 inch thick sheets of aluminium zinc alloy to protect them from Jupiter's intense radiation. The brains of the spacecraft, or the computers, include flight software and more. The vault is bolted to the spacecraft's propulsion module and has wires to communicate with and control the entire craft. On launch day, Clipper will weigh approximately 13,000 pounds, about the weight of a full-grown male African bush elephant. Nearly half of the spacecraft's weight will be fuel, nearly 6,000 pounds worth of propellant. Currently, Europa Clipper is on course to launch in October 2024 on a SpaceX Falcon Heavy rocket from Kennedy Space Center in Florida. The spacecraft will fly by Mars before circling back to Earth, using the gravity of each planet to increase its momentum. This tactic is called a gravity assist, and will provide Europa Clipper with the velocity needed to reach Jupiter by 2030. Once Europa Clipper begins orbiting Jupiter, the spacecraft will spend about a year altering its trajectory in preparation for its first Europa flyby. The spacecraft is expected to spend 3 years soaring past the icy moon countless times and sending the data back to Earth. Over the course of the mission, the spacecraft will investigate nearly the entire moon and what she has to offer. NASA is not the only space agency conducting similar research on Jupiter's famous Galilean satellites either. The Jupiter Icy Moons Explorer, JUICE, by the European Space Agency, ESA, will seek to answer some of these questions as well. However, instead of focusing on Europa like NASA is doing, the ESA will be investigating the details of Europa's sister moon, Ganymede. Depending on the results of this mission, NASA has created a concept mission, the Europa Lander. Since the moon is thought to harbor a secret ocean of salt liquid water beneath the ice, scientists believe that complex life could exist in said ocean. If we're right, signs of this complex life, like biosignatures, could potentially find their way to the surface. And if that's possible, then a lander could sample and study said biosignatures. The Europa Lander would investigate signs of life on the surface and collect samples from roughly 4 inches beneath the surface. This is a depth scientists believe the complex chemistry from the ocean below would be protected from the damaging radiation Jupiter emits. The lander concept would adopt many of the similar practices used with the Mars rover, including a mini laboratory within the robotic lander. In addition to the proposed chemical analysis lab, the lander mission is considering equipping the spacecraft with a microscope and a camera, along with a seismometer to detect geologic activity. For now, the mission will stay a concept until the time is right. Scientists aren't even sure if the surface of Europa is completely solid or simply appears to be. Attempting to land a rover without proper knowledge of where it could land, let alone maneuver, is a recipe for disaster and disappointment. For all we know, the weight of a land could crack the icy surface and it would fall into the mysterious ocean beneath. Until the concept becomes reality, Europa Clipper will be the star of the show in uncovering the secrets Europa is keeping from us. If you liked this video, please be sure to like and subscribe. Let us know in the comments if you think Europa Clipper will discover the first signs of extraterrestrial life or more.